this video, we are going to design a logical circuit to control the access to a bank. You see in this picture, there is a double door system, and a person cannot enter directly into the bank, but he or she has before to pass through the first door, and then the first door closed, and only at this point the person can enter the bank. So we are going to design a circuit that can manage this system of double door access to a bank. Here you can see a more schematic description of our system. Here is the bank, and here we have the two doors. I called them D1, door 1, and D2, door 2. And we have a button, a push button outside of the first door. And the person who wishes to enter the bank had first to push the button B. And then we have a sensor or transducer here who can detect the presence of a person inside this space, because another person cannot enter if there is a person inside, and the second door will open only when a person has entered from the first door and the first door has closed. It is important to distinguish here between the input of our logical circuit and the output. The input are data that go into the circuit, and of course the external button is an input, and even the sensor of presence here is another input of our system. And we suppose that each door has a mechanism that can open or close the door, and this mechanism is controlled by our circuit. So D1 and D2 are the two outputs of our logical circuit. So here I described the circuit using a truth table, and let me explain it to you. In this truth table, we have the two inputs B and S and the two outputs D1 and D2. And here we have all the possible values of the two inputs as usual, 0, 0, 0, 1, 1, 0, and 1, 1. First of all, I have to explain this correspondence between I arbitrarily choose to correspond 0 to unpressed in the case of the button, to blocked for the door, and undetected for the sensor. And in the opposite, I have chosen the value 1, which means pressed, unblocked, and detected. And I want to emphasize that these two values are totally arbitrary. We could also choose the opposite way, but it is important to state what you want to choose, because it is important to have clear the meaning of 0 and the meaning of 1 in our case. So I repeat, I have I wrote here my choice, arbitrary choice, that 0 means this and 1 means this. So now we can explain the truth table, because 0, 0 means that B is unpressed and the sensor S doesn't detect any person inside this small room. So in this case, I blocked both the door. 0, 0 means blocked this one and blocked this one. The second row is 0, 1. In this case, there is no person outside pressing the button B, and there is one person inside because the sensor detects a person inside. So in this case, I want to block the external door and unblock the internal one. And 1, 0 means that there is a person pushing on the button outside, wishing to enter the bank. There is no person inside, so in this case, we are going to unblock the external door and block the internal one. And the last case, 1, 1 means there is a person outside and there is also a person inside this space. So the best way, I think, is to allow the person which is inside to enter the bank and to block the entering of the outside person. So in this case, we are blocking the outside door and unblocking the inside one. And that's all for the truth table of this circuit. And now I want to create a circuit which realizes the truth table of our controller for the access to the bank. And of course, we need two input pin, B and S. And we also need two output pin, D1 and D2. And instead of trying to create the circuit ourselves, we are going to use the tool, the powerful tool of Logisim for creating circuits. We already seen it is analyze circuit, but in this case, you see the truth table is completely empty. And the reason is because there is no circuit, and so in the truth table, you see all this X means that there is no truth table. And I'm going to fill this truth table according to what we previously designed. So 0, 0 is 0, 0. We have to click on this and this. And 0, 1 is 0, 1. 1, 0 is 1, 0. And 1, 1 is 0, 1. So you see this truth table is now the same as before. And now I'm going to click on build circuit. I show you. I click on build circuit here and to click on OK and then to yes. And you see Logisim has built automatically a circuit which realizes our truth table. It is quite easy to check it if you want. For example, 0, 0 is 0, 0, 0, 1 is 0, 1, 1, 0 is 1, 0, and 1, 1 is 0, 1. So you can see the behavior of this circuit is exactly what our truth table describes. And you see it's quite easy to design a logical circuit. You have just to fill the truth table with the right values, and then Logisim is able to find the right circuit from the truth table. And I want to simply notice that in the case of the D2 output, there is just a wire connecting it to the S, to the sensor input. And the reason is because if you watch the truth table, the output D2 is equal to the input S. So whenever the input S has a 0, the output D2 has a 0, 2, and whenever the input S has a 1, the output D2 has a 1, 2. So I think that's all for this video. Bye to the next one.